Okay, let's start. This is lecture 13 for CIS6395. So we will finish the malware case study, malware dynamic analysis, and then we move on to the next topic, which is about penetration testing, the first stage in penetration testing. Reconnaissance just means collecting information on target. So that's the first stage in any attack. As I mentioned last time, I have decided the midterm exam time, which is next Wednesday. Basically, next Wednesday, there will be no class, and I will release the exam question about 10 a.m. in the morning on Wednesday, then till next Thursday midnight. So you have basically 2 nights to work on the exam question. Because some students, they are working full-time. So I give this 2 nights time for those students that cannot do it in the daytime. So that's the midterm exam, as I mentioned in the announcement. It covers every lecture content from the beginning to this dynamic malware analysis. So all the content are covered here. It's just a special homework assignment. The only difference is that the time is short. In addition, you should not consult with another student, try to get answer. You cannot work together on getting the answer for the question in this. It's not like in homework. The other homework, you can ask other students, you can ask me to try to find the answer. So, but for the midterm, if you have question about the explanation on the question itself, then you can ask. But I will not help you to give you some hint, to give you some partial solution to the midterm exam questions. Okay. One thing I want to mention that in the midterm exam, you need to use virtual machine. So, for the student who haven't installed VirtualBox and the Windows virtual machine, you should do that beforehand. And if next Wednesday you find out that, well, I cannot run VirtualBox on my computer, or I cannot download this very large Windows virtual machine image from Microsoft website, then that will not be any excuse for not be able to do this midterm exam. Okay, so that's for the midterm exam. Let me finish this malware dynamic analysis. So as I said, yes.
I'm sorry to interrupt you. For the midterm, is there any like study guide document that we could look to make sure we know what we need to know before the exam?
There is no additional document. Basically, the lecture slides I will cover, or whatever I will test in the exam will be covered all in the lecture slides.
And one more question. Are we allowed to use the lecture slides during the exam, or is it closed book?
Can you repeat the question?
Are we allowed to look through the lecture slides if we need help with a problem on the exam, or is it a closed book exam?
Oh, no, this is just like a special assignment, homework assignment.
So we can use the PowerPoint.
You have access to internet. You have access to all the lecture slides. So it's not closed book. It's open.
Okay.
Just you do it in your own pace and give you just 1.5 days to finish it. Another question that some students may have is that what kind of Windows virtual machine image you should use. You can use the Windows 7 VM image, Windows 8 VM image, or Windows 10 VM image. There's no difference. So as long as you download one of those Windows VM image, remember they are very big. So if you haven't done this before, try to download it now. Don't wait until the exam time starts, then you find out that you don't have a Windows virtual machine image in hand to use it. Then if you download at that time, you may not have time to finish the downloading if you don't have very good bandwidth. Is the Windows VM the only VM that is needed? The answer is probably you need also need to use Kali Linux. So Kali Linux VM is also needed. Yeah. So just download at least these two VM. Okay. Any other questions? Okay. Let me move on to this one. As I mentioned, we try to use OLE debugger to dynamically checking the program running status in order to find out what kind of hidden password in this robot authenticate program. OLE debugger, once you open it, this is the default window for that OLE debugger. Basically, the first window will show the disassembly language for that binary program you just opened. And this window shows all the CPU registers when you run the program at any moment. Because when you run the program under OLE debugger, you can set up breakpoint, and you can break the program running at any instruction. Then this register, this window will show when you break this program, what's the content in all the CPU register. So you can see that the EAX, EC, ED, EB, so A, B, C, D, these are common register. And this ESI, EDI, these are all common register. ESP, EBP, they are used by stack and by operating system. I will mention stack a moment later. Let me see what's the question. Oh, the question is that I'm unable to run both Kali Linux and Windows VM at the same time. Is there any reason for that? If you cannot run them at the same time, I think for the midterm, there's no problem. But later on, when we do penetration testing, you need to use Kali Linux as attacking machine, use either Windows VM or Metasploitable Linux VM as a victim machine. When we teach penetration testing, you need to run two VM at the same time. Right now, just one VM is fine. So for the midterm, you don't need to worry about running both, but you need to solve this problem. You need to run both. If your computer has too small memory, then you can set up the setting on your Kali Linux VM and also your Windows VM to shrink down their memory, so that your computer memory can support them. Because let me show you. Because by default, this Kali Linux VM, once you install its system, if you click the system, the base memory, by default, it will use 2 GB memory. So if your computer is old, only has like for example, 4 GB internal memory, then this 2 GB memory for the VM may be too much. Because this 2 GB means it will exclusively use 2 GB internal memory in your computer. And so if that's the case, then you probably need to shrink down, for example, to 1 GB memory for your Kali Linux. Of course, your Kali Linux will run slower, but it can still run with 1 GB. Windows, I don't know what's the default memory setup. The default is probably also 2 GB. So you can shrink down to like 1 GB. Oh, I think 500 MB is too small for Windows 10 or Windows 8. So 1 GB is enough for you to start to run. Another thing is that if you want to change the configuration, you need to shut down that corresponding virtual machine. Then you can change the configuration. Otherwise, like right now, I'm running these two. This one is running, and all these configuration, you can see that it's all gray. Basically means I cannot change any setting here because it is running. You have to shut down the VM in order to change the configuration. Okay, so all the debugger, this part is memory dump. Basically, this will show the actual memory content of the disassembly language. So whenever you click any instruction here, the corresponding binary will show up in this memory dump section. And this will show the actual stack. Because if you run any program, you will have a lot of function call. Every function call in Windows, in Intel architecture, it always use stack to save that function calls information. So this will show what actually is saved on the top of the stack related to the current subfunction. Okay. So let me show that. So I have downloaded all the debugger on my Windows 10 virtual machine. So if I open it, it will give you some warning, like you don't have administrative right or something. Just don't worry about that because we are not using those privileges. Then you open that executable, like this robot authenticate. Then this is the default display. So this is a disassembly language because all the debugger will disassembly a binary code and show its machine code. And only debugger has some other feature that I will show a moment later. Like it will, like this part. So this is a disassembly language. This is show the memory, this absolute address, or the relative address. And this part is interpretation of the only debugger on the disassembly language. Because sometimes it can find out, like sometimes it find out that the above, these block of binary code is corresponding to the put function. Because the only debugger understand the major programming language. Any major programming language, when they are compiled, their function call will have a very fixed pattern in generating the assembly language code. So only debugger know that this section of binary code is actually corresponding to this put function in C language. Then it will display that these are just a high-level interpretation of only debugger to show that, well, this part of code corresponding to the put function call. Because you can see this, this is a put, this is ASCII string. So you can see that, well, if you remember robot authenticate, it will first print out some ASCII text to show that robot picture. So this is actually the robot picture. This put is a printout by this program. Because put is a string output. You can output to another string, or you can output to standard out, which is the computer screen. So these, you can see that, well, these have many interpretation, basically help you to see the assembly language. Otherwise, the assembly language has so many lines, it's very hard for you to read. So this part is very useful. And this is the CPU. This is a CPU's information, like because right now I'm not running this program. So this one just show the current CPU's register content. This IP is instruction pointer. Basically, it is used by the CPU to save what's the next instruction to fetch. So that's the address for the next instruction. And EFL is extant flag. Remember, this is a flag register. Whenever you have any logical computation, it will change some bits, corresponding bits in the flag register. Then this conditional jump, they will use this flag value in this flag register to jump to the corresponding execution path. So that's this, and this is binary. This is a stack. Basically, right now it's the initial stack content. This is actual stack content. So that's the OLE debugger. Okay, so once you load this program into OLE debugger, you can start to run. You can click this button to actually run this robot authenticate under the OLE debugger monitoring environment. And the first run will actually start the program to the first instruction. So it doesn't immediately execute the program. But when you click the second run, it will start to run. Like right now, this is so if you can click debug and run, then you can see this command line window. Okay, so I think this version has changed that. If you click run, it will actually execute the program. So you can see that the program has been executed and stopped here, waiting for the user input. And you can see that where it has been going to. So right now it's actually executed to this instruction. And this is current CPU's information. This is the stack information. So if I type in arbitrary password, then you can see that, well, this one actually finished because, and this one actually finished running. And the last instruction is here because it shows up at the top of this window. So you can see this is return and basically finished that main program. And this one has finished because if you input the wrong password, it doesn't give you any remind and just close the program. Will cause the program to terminate. So how do we analyze this one? Again, it's for any binary code. The first is the static analysis. Is you try to find ASCII string in it, because ASCII string will tell you a lot of information. So under OLE debugger environment, you can use this way to check the ASCII string in the assembly language. Once you load the program, like before you start to run the program, you just right click any instruction, then search for, then all reference text string, then it will show all the text strings in the program. So let me do this. Because I have finished running, so let me reopen that program. And on any instruction here, I just right click and search for all referenced text string. And it will show you another window. So if you make it bigger, then you can see that these are all the text string in the program. So here, this is not the same output as when you use this string command or or the other static analysis command to show the ASCII string in a program. In static analysis program, in the static analysis, like when you use the strings functions or PE browse professional or this PE Studio to open the program, it will not interpret the program. It will just find if there's any consecutive byte that can be represented by ASCII character, then it will print out. So there are many ASCII strings in the static analysis program. The many ASCII strings that they actually not ASCII string. They are just happen to be some ASCII character combined together. But here the ASCII string is the real ASCII string that in the program, because all the debugger, remember it has disassembly the binary code. It will know what kind of variable is ASCII string array. So these are the ASCII string. So you can see that well, it's very small. Let me make it bigger. How do I make this font bigger? Well, I don't know right now how to make this bigger, but so it's a little bit small. So you can see that, well, this is a very long ASCII string. So this actually corresponding to that robot picture. It use ASCII string to print that out. This is percentage 20s is basically percentage s. And you can see here, this one, you pass the level 1. So it must be the printout message once you pass the level 1 password. These are some other internal printout. Suppose the robot authenticate running has some problem on the computer. It will print out some error message. So these are just error message in the program. Like when you write your own program, you may have a lot of error message print out. So these are just some error message in the program. For example, if the robot authenticate cannot generate a dynamic allocated memory, it will have some error message print out. If it cannot open some file, it will have some error message print out. So these are just some error message. So this one is important because it shows that this and the first window here should show the corresponding instruction that use this ASCII string. So that means this instruction must be the instruction after we put in the correct password. Basically, this instruction must be very close to the instruction that actually do this string compare to find whether your input password match with the system password. So you can see the string that we can guess that for that assembly code will compare our password with the real one. Then, because this program is very long, so we can check this instruction to follow, to only check the assembly language around that instruction. Then we can manually read that part. So to go to the string in the assembly language code, we right-click on this line to select follow in disassembler. Basically, this is instruction that is very close to the actual string compare of the real password with our input password. So we can just right-click and following this assembly, then you can see that the first one in the window is the instruction that has this upass level 1 command. So it means that the instruction before it must be some instruction that check the password. And we can clearly see that here, this is a string compare. So string compare in C language is compare two ASCII string to see whether they are equal or not. So that is the instruction that actually do the string compare. And the actual assembly code is like this. This call, remember, this is a subfunction call. This subfunction call basically is a string compare function in C language. So this call will do this string compare. Then the test EAX, because this string compare will save the output in the EAX register. This test EAX and jump not 0 basically check whether if the EAX is not 0, it will jump to this part. Otherwise, it will move next to run this instruction. So if the EAX is 0, then this will run. So that means our password has matched with the real password. So now we know that this is a place where the real password will be revealed to us. However, static analysis cannot see the real password. We have to do dynamic analysis, and we set a breakpoint at this point. So when the program runs into this part, we pause the program, then we can check the memory and register value and memory value to find out what's the real password value. So that's a basic idea for that. So we can see this string compare instruction, and we can also see some previous function, like this is a string compare. We can go up a little bit. You can see that here is a scanf. Scanf is the read user text keyboard input. So scanf basically reads the user input password. String compare reading user input password with the real password. Then if it match, it will use this put function to print this text to the screen. So that's the basic instruction flow for the program. So now we can start running. In the runtime, we check the memory. So we need to set a breakpoint in this call. Basically, when this string compare function start to run, we will pause the program to check the memory. We set breakpoint, and we can breakpoint. The OD debugger support several different ways to break point. For this program, we use this breakpoint memory on access. So whenever it access memory, this one will be breaked. So what's the difference between these conditional, these breakpoint, these several ways to set the breakpoint? Then for that, you probably need to read more, and also read other people's tutorial on OD debug to see what's the difference between those breakpoints. So we come to the string compare function, then we right click and we set breakpoint and memory on access. Maybe the other breakpoint way is also work, but this is a way introduced by that blogger. So once you set a breakpoint, you can start to run the program. But why do we set breakpoint in that string compare function? Because string compare function will have the user input string and the system string as the input parameter. And And for all the subfunction call in Intel architecture, whenever a subfunction call is executed, the subfunction will, this will be the stack memory information. Basically, when a subfunction call is called, the subfunction's local variable will be created here, and all the base pointer will be saved here. Remember, BP and SP, they are the EBP, ESP. They are the two registers used for the stack. So these are registers used by the operating system to find out how to manage the stack. So the SP, the stack pointer, always point to the top of the stack. Stack grow from higher address to lower address. So the top of the stack is basically in the bottom part. So stack pointer is always point to the top of the stack, and the base pointer basically point to the beginning of this subfunction in the stack. So previous base pointer will be saved here, and base pointer always point to this part. So the stack memory is managed by the operating system. It is allocated in this one subfunction. You put another subfunction call. If you have another subfunction call, it will put on the top. So just one after another. The base pointer is used as address, linked list. Remember, if you learned data structure before, it's like a linked list. Every subfunction memory on the stack is like a block of memory. How do you find one block to another block? This use a linked list. The base pointer is used for that purpose. Anyway, why do we care about that? Because the subfunction's parameter, input parameter, will be pushed to the stack, will be saved here. And string compare, if you see this function, this string 1, string 2 will be the input parameter to the string compare. So that means that the user input a string and also the system real password string, they will all be put to the stack. And in OLE debugger, we can see the stack memory content. So that's when where we can find the real password. So so right now, remember, we have set the breakpoint, and we can start to run the program. And now we can input a password. For example, I input a clear password, for example, because I input this one in order to make sure that when I see this in the memory, I know this is one I input. And if you press enter, you can see this in the background, OLE debugger has changed and changed to here. So this is instruction right now because we paused the program here. And the CPU, this is the register. And this is the stack. So you can see the stack, right? That right now, this S1 string is my input. This is S2 string for the string compare. This is two input parameters for the subfunction. Remember, in this one, we say that input parameter will put in the stack first. Because we paused the string compare, we haven't entered the string compare. So in the stack, this part has not been put in the stack yet. But we can see that this is S1 string, this is S2 string. So it's clear that this S2 string must be the real password for the first password puzzle. You can do like here there is a debug. You can go like a step into. Step into means step into the subfunction call. Step over means that you can run the program until the current subfunction call is finished. So if we do this step into, and this is that's a function calls instruction, and you can see that we have called into this, and step into that it will run the next instruction. So it will just run one instruction at a time, and clearly we can see that they are still in a stack. So now we know that this must be the first password. So we can try this password by ourselves to see whether it works or not. So we can use command and so let me turn off this program, terminate this debugging program. You can debug, you can stop, step over, step, close. It's still active, so I want to terminate this program. Unable to terminate. Because I have already terminated. I have closed that window. So now I want to run robot authenticate by myself. And now I can try to input this password. This is R0B0 RULEZ explain sign. And now you can see that, well, you passed the level 1, and please enter the second password. So we have find the first password. So that's the first puzzle that we have solved. Okay, so that's all for this puzzle. The second password is harder to find. It needs some additional technique. It's not just this simple string compare to find the password. Any questions for this case study? We only use the very limited function in OLE debugger. OLE debugger has many other functions in it. You can see that it has a lot of menu.
Is finding the second password outside the scope of this class? Is it too complicated to get into?
The second one, there are some other people write some online document to show how do you solve the second one. But yeah, it's more complicated. And so I will not introduce that. I don't have time to for the second one.
Okay, thank you.
Yeah. If you are interested, I can try to find any online writings on solving the second password. Then I can maybe send out an announcement, put that link in the announcement. So then for any student who are interested, you can check those writings.
That'd be awesome. Thank you.
Yeah. Okay, so now let's move on to this reconnaissance, the penetration testing. The first reference, yesterday I couldn't connect. Maybe their website is down, or maybe it has been moved out of their website. Let me see. Yeah, I think this web server is down. So I cannot download it again. Anyway, these are the two references that I use some slides from them. So for attack, what are the reasons that attacker attacks computer system? There could be many reasons. First is profit. Like in recent years, like this ransomware become more and more popular, attackers use ransomware to attack many. Well, they don't use ransomware to attack big companies. They usually attack a smaller company, like a town or a city's department, because those targets, there are so many such kind of smaller targets, and it's very easy for attacker to successfully compromise them using ransomware because their IT support team is not good enough. And once they compromise those smaller business, like a small city hall, town center, or police department, the attacker can ask for some ransom, then those city, they will pay for those ransom because they want to return to their normal operation. So that's the sheer profit reason, and profit is the #1 reason for attacker for the current cyber attack, because attacker can sell like a stolen credit card information. Attacker can sell them in the black market, and stolen like a social security number. Attacker can also sell them in the black market. So profit. Another is altruistic reason, because some attacker, they believe certain philosophy, certain principle, so they will treat some business as enemy, and they will attack those enemy, those business. The attacker could range from the first time people who actually try some attacking software, doesn't know what they are doing, just to try the attacking software, which is very easy to be detected and blocked, to some serious attacker, like a state hacker, basically doing hacking for some country, then those are most experienced hacker. So these are the 5 stages for any cyber attacks. First is reconnaissance. Reconnaissance is information gathering. Reconnaissance usually means that you gather information without causing any alert to the target. Basically, gather information that the victim will never be aware of. So because you will never probing actively interacting with the target system. Second is the scanning. In the scanning stage, you actually sending some perturbing traffic or probing traffic. You actually interact with the target in order to get more detailed, concrete information of the target. Like for a computer, the most dominant scanning activity is that we use Nmap to find out what computer is online in the target system, which part is open on a particular IP address on a particular server in the target. So that is a scanning. And you can get not only which computer is online, you can also know what kind of operating system that computer system is installed, and what's the software version. Like if it's a web server, then you know what's the web server software, what's the version of that web server software installed on that computer. Then you try to gain access. And once you gain access, you try to maintain the access, because attacker can get more profit. For example, if you are profit purpose, you can get more information, more secret information if you stay in the compromised system for a longer time. And if attacker finished their activity, for example, they have successfully get a trade secret from a company. Before they leave, they will try to cover their tracks and to make sure that they will not be discovered, or be discovered as late as possible. Because if their attacking behavior has been discovered like 3 months away or 5 months away, then the information they have stolen will be more useful. For example, if they stole the e-commerce website, the customer's credit card, or login account information, then if the e-commerce does not discover that, the attacker can sell these accounts and information. Then the other attacker, they can use these information to do like identity theft or something. But if they are discovered right away, the e-commerce will inform their consumers that their credit card may be stolen, and this credit card may be updated. And the consumers, they may also update their account password, make their account much harder to be entered. So covering track is also very important for some sophisticated attackers. Normally these are the 5 steps for cyber attacks. So we look at the reconnaissance in this first stage. Purpose of reconnaissance is like, in analogy, it's like if you want to rob a bank, you need to do a lot of information gathering before you actually do this robbing. You want to find out when the bank is open, like how many security guard, when this armed truck will come in to remove the cash from the vault, and who is in charge of the vault, who is the manager. So all this information you need to gather before you do any successful attack. For cyber attack, this is also the reason that you need to know a lot of information about the business, about target. Like you need to at least know who are the employees for the business. And then you can attack those employees through many other ways. Who are the employees? Which one is in charge of HR? Because HR may have access to all the human resource data, which is very useful for attacker. Who is in charge of the database? Who is the IT management person? So that person's account may be more useful for attacker. And what kind of security software have been purchased, have been used by that company? Then you can try to attack the vulnerability in that security software. Whether they have installed a firewall, or whether they have used a two-factor authentication for the employee, or just using simple password for their employee. So attack reconnaissance, there are many different ways. So low technology way, like traditional way, is using social engineering, physical reconnaissance, like a dumpster diving belong to physical reconnaissance. You gather the dumpster, you gather the trash, and the company employee, they may throw away some document without shredding them. This document could reveal many information. Social engineering, we all know that social engineering, even in today's internet, many cyber security breach incident for some big company, they start by social engineering, because attacker, this is most easy way for attacker to put their foot into a company. Because the company has many employees, it's very easy for them to find some employees that have no idea about security. Then attacker can use social engineering to get those users information, like login account information, password information, and like social engineering, you can use a phone call or send a fake email behave from system administrator. Like this email, read like this email is from the IT support team member, and say that your computer need to be upgraded, or your account, you need to change the password or something. Then you follow the link, you will actually change the password, and the attacker will know that. So this is a social engineering. So most attack in recent years, they start from social engineering. It's not like attacker find a software vulnerability, they use software to actually compromise an internal machine in a company. Most attack is because of social engineering. So attacker use this way to log in to the company computer. Like ransomware, the majority of ransomware attack they are successful because some employee in some business, they have fall trap to the ransomware, usually is a phishing email, and click some link and then cause their computer to be compromised. So social engineering works because it exploits human vulnerability, like a desire to help and the fear of getting into trouble. This one is very powerful. I have the personal experience. Like a few years ago, I received a phone call saying that it's from Chinese consulate in Houston, said that my password or something has some problem, and so it looks scary because, well, I still want to visit my family member in China, so I need to talk with them, and so that is actually a fake phone call from some scammer. They target those Chinese people here. They say that you have some trouble, you have some issue with your visa, with your password, with your information, then you need to explain some information to them. If you trust this phone call, then you may reveal your password. You may reveal your password, passport, some detailed information, or even your social security number or driver license number to them if you fall to the trap. So social engineering is not just about phishing email. So right now, the most social engineering is through email spam, the phishing email. But social engineering can be a phone call to you by a real person. It could be a text message to your phone, to your smartphone. Say, some text message say that this is from the police department, and you have some ticket or something unpaid or something. So social engineering, the fear of getting trouble is a big factor to make some people fall to the trap. Before you think clearly about that, because of the fear, you immediately answer the question. You immediately click the link on some email, and then you will be exploited. And social engineering is easy. Sending phishing email is very easy. Sending a fake email is very easy. You can use some existing software tools to do that. And make a phone call is also easy. Attacker can make phone call from computer. They don't need to make a phone call from a real phone. So it's very hard for you to trace back to find where the attacker is. Just like phishing email, you don't know who sent this phishing email. And also sending fake text message is also easy. And especially for phone call, attacker can, because you can get a phone number very easily using online software service. So if you call, so suppose you want to fake as a phone call from the police department. You know the police department phone number. You can get a phone number very similar to that police department phone number. Using very limited amount of money, then you can use that phone number to call any person. So if they see that this is a phone number that looks like from the police department, even if they check the website, it looks like the same number. Maybe one digit is different, but only the last digit is different. Then you may think that, well, this is a real phone number from the police department. So there are many ways for attackers to do that. But traditional, if you use technology way, it's much more complicated. You need to scan a computer. You need to find the vulnerability. You need to find the corresponding attack to that vulnerability and compromise the machine. It could take a lot of skills and time, but social engineering, you can just make a phone call and you can get a fearful employee's password and login credential. So how do we defend against social engineering attack? Because social engineering attack is not a technical way, it exploits humans vulnerability. So the only solution for the defense is the user awareness. So for your employee, you need to train your employee to be aware of those social engineering attacks, all kinds of tricks, not just the computer-based, like email. We all know email is there could be some fake email, but many employees, they are not aware of phone call spam or text message spam or like Twitter spam, those social network spam. So you need to have this user training from time to time to train them to be aware of all kinds of tricks. In addition, many companies, they actually do this. They will hire some security company to do a spam campaign. Basically, they hire some security person to send out a phishing email to all their employees. And if any employee fall to the trap and click any link, then it will be redirected to these security companies, and then security company will show the web page to tell the employee that you have clicked the wrong link. This is actually a phishing email, and you need to be aware that this is a trick. What kind of trick the attacker have used to lure you to click that link? So basically, that is like a drill. It's like a fire drill for the employee. And also, the employee information may be passed on to the manager. So manager knows that among 100 employees using this phishing campaign, 10 employees have clicked this crafted phishing email. So the manager can let those 10 employees to go through additional training. So that is this phishing campaign is used regularly by many companies for their employee training. Even in UCF, I think maybe half a year ago, the IT support department, they have sent a all university-wide spam campaign. Send everyone an email. If you click any link, you will be redirected to a page. They will tell you that you need to go through a web course training. They will actually create a web course to you. You need to go through that training to pass on this. Physical reconnaissance is like a tailgating, follow someone enter the security gate. So that is one. Shoulder surfing, tailgating defense is, well, just to make sure you follow the protocol. Don't let anyone in without getting the security gate. Another shoulder surfing is just to look through your shoulder to see what you type on your computer, especially if you use your laptop in some public place, like in coffee shop or in airport. You should be aware anyone behind your shoulder to know that your login actions. Dumpster diving is recover some copies. So for a company to defend against this, then that means that for all your unused throwaway documents, you need to shred them. For unused or throwaway electronic stuff, for example, broken USB key, broken hard drive, broken soft disk, you need to make sure that all the information has been erased, like goes through some magnetic erasing machine to make sure that all the magnetic signal will be erased off. And of course, secure your cache area. So, but of course, for this class, we focus on the technical aspect of the reconnaissance. For attacker to get the information on a victim, they can do this many ways to get the information. First way is that get information based on the domain name, because for any company nowadays you have to have some website or some other computers, so you have to have some domain name. But the domain name registration information is the public information, so any internet user can get that information. And So to find out domain name, we can use this command called whois command. So whois command is basically query this internet organization to find out who have registered a specific domain name, and the registrar's information will be shown. So one way you do whois is that you can do it in Kali Linux. It has included in Kali Linux. Let me show you. It'll take some time. So whois is a command. You can just like whois, like UCF.edu, you find out who have registered the UCF.edu domain. Then it will tell you a lot of information about that. Like who is like UCF.edu. Then we can see that this is answer. So these are just the top information. The domain name UCF.edu, registrant is this University of Central Florida, and so these are the organizations who have registered, who have got this domain. And here is administrative contact. So the contact person for this domain, technical contact person for this domain. So these two information are important for attacker, because then attacker knows that at least two persons detailed contact information that in charge of this domain, especially those two persons are the administrative technical person. So maybe attacker can use this information and send out the email, for example, fake as this Thomas Annis, and send out a spam email to employee in UCF, and because he knows that he's a technical person, then he can say that your account in UCF or your email account has some trouble, and you need to reset your password or something. So that is a phishing email. So you know this administrative contact information. Here is the name server. Name server is official authority DNS server. Basically, all the smaller domain like cs.ucf.edu, mass.ucf.edu, all the domain name and IP address mapping is given by this authority DNS server here. So authority DNS server provides official answer for the IP address to domain name mapping within UCF.edu domain. So here is this one. So that is whois. If you want to find like some organization like whois CNN, and you can see that this is organization name, like CSC Corp domain. And the registered organization is Kernel Broadcast System. So you can find out who owns a business and some contact information, phone number, and the email address, the technical contact person's email address. So this is whois. It's very simple, but it's a good information for attacker to know, and this is public information, so anyone can have it. And you can use online. There are many online whois service to do that as well. So if you don't have Linux, you can use online service to find that. For example, you can just check whois lookup, and any one of them, suppose. So like UCF.edu. Oh. And this is who is showed that the registering organization, and also showed, so this is actual answer. You can see that administrative contact, technical contact, it's the same information we get from the Linux. So there are many websites provide this WHOIS service as well. So you can look up company name, domain name, IP address. IP address, sometimes you may not know, because I think here there's no IP address. It's just the company name, contact person information, and this name server is the authority to DNS server for that domain. So those are the information. IP address may not show up. Like this is because I copied slides from them. So this is a slide showed for that particular company. It showed the registering information, the domain name, the phone number. For the American continent, this ARIN is an internet nonprofit organization in charge of the domain registration, IP address registration allocation. It's by ARIN. So you can go to this website and do the WHOIS command as well. In Europe, it's by RIPE NCC. So that's the organization in charge of Europe continent IP address allocation or domain name registration. So you can also do some other check. Remember, another type of check we mentioned before is the traceroute. So you can do traceroute in the internet. For example, online traceroute, and you can use any of those websites. This is Network Truth, so you can use any of these websites to traceroute to a specific IP address to know where the location for that IP address. You can use IP location service to find what's the location, IP location. To find out what's the physical position for that computer, for the specific IP address for the computer. So all these online tools you can use to do reconnaissance, and the victim will never be aware that you are doing this information gathering, because remember, you are using some web service to do it. You are not doing this action from your own computer. So attacker will never know that you have done some information gathering on that. So that's the first one, is the WHOIS, use the domain name information. Second information gathering is this Wayback Machine. It's basically called archive.org. Wayback Machine is very powerful. It's you can think that it's like a different type of Google. Google search engine is basically browsing through the whole internet, get a snapshot, and get the keyword index, so you can Google search and quickly find the target that contains that keyword. Wayback Machine, on the other hand, it also crawls through the whole internet. Then it tries to save every page it has crawled. Of course, it may not save those pictures or something. They may only save the text. Then it will save those information for a long, long time. That's why it's called Wayback Machine. Basically means that for any popular website, maybe some unpopular website, the Wayback Machine will not save them. So Wayback Machine will save a snapshot for example, for UCF computer science website. It saves a lot of snapshots of this particular cs.ucf.edu domain. And how many snapshots saved is depend on their algorithm. They will consider how popular this website is. If the website is not popular, then Wayback Machine will crawl the website once a month and just save a snapshot once a month. If the website is very popular, the Wayback Machine may have a snapshot of any web server once in every 1 day or once in every several hours. So that's the Wayback Machine. So I can show you this is, you can just Google Wayback Machine and connect to that. For example, if I want to check, here you just input domain and browse history, then it will show all the snapshots of the cs.ucf.edu in a history. So you can see that in 2021, here, so right now is 2021. So you can see that here is a snapshot. Take the closest snapshot was taken in June 29, 2021. And here is a snapshot. Basically, on the same day, there are two snapshots. So here just showed how many snapshots have been taken. So if I come to 2005, I came to UCF Computer Science Department in 2005, and if you show like this August 31st, there is one snapshot. If you click this, then you can see what the actual CS website looked like in that particular day in 2005. So this is the website. And so it actually saves some picture. If the picture is not object, picture, video is not big, the Wayback Machine will actually save some copy. So you can see like people and like faculty. And you can see that at that time, who is like department chair, who is a director, and some faculty like Dr. Basoni, he has long retired, but that time he's still here. And if you go down, you can see my information. But if I click here, there's no snapshot anymore. So you can see that the Wayback Machine has not archived this URL. So for the website, it may not archive everything because a website may have too many content. It will only archive a website to a certain level down. How many level it archives? Wayback Machine has its own algorithm. If the website is very popular, it will archive to a deep level. If the website is not that popular, it only archive the first level, second level, or maybe third level, and that's it. It will not archive everything. Otherwise, the Wayback Machine don't have that much storage to save everything. But you can see that my information is here as assistant professor. So this is the Wayback Machine, and you can find in other snapshots, like for example, if you are interested to know, like in 2016, what are the employees? Suppose you are a hacker, you want to attack the company, a company. You want to find out who are the employee, not only the current employee, but also some previous employee. Then you can use Wayback Machine to browse the company's website, like 1 year ago or 2 years ago, to find its employee list. Then you can find some prior employee information. And also, maybe there are some published web page that contains some company secret. Wayback Machine may also have that because sometimes a company may publish too much information Then a few days or a few weeks later, the company realized that that information is confidential. They should not be revealed to the public. So the company will delete that corresponding page. But Wayback Machine, it will have all the snapshot. So if you browse through the snapshot, you can find some secret information about the company that in the current web page you will never be able to find. Okay, I think time's up. So when you go back, you can try the Wayback Machine by yourself to find many interesting things that you can find. For example, what's the beginning? What's the first 5 years of Facebook? Facebook looks like, or Twitter looks like. Those are very interesting things you can check. Okay, that's all for today's class. See you next Monday.
Okay, see you Monday.
Thank you. Bye.